Okay, let's do just the front side of these today. We're going to continue on in lesson 6.2. Yesterday, when we did these, our fraction exponent always had a numerator of 1. So today, the fraction exponent is going to have a numerator greater than 1, and then it can be rewritten as a power to a power. So instead of it being b to the 1 over n power, we're going to say today it's not going to be a 1, so we're going to call it m, first of all. So if we have b to the m over n power, m over n is our fraction, we can rewrite that as b to the 1 over n power, that taken to the m power. Because remember, when we take a power to a power, we multiply their exponents. So if we have 1 over n, and we're going to multiply it times m, we can make that into a fraction by putting it over 1 so that we can see 1 times m upstairs is m, n times 1 downstairs is n, so we do end up with b to the m over n power. So that property helps us to be able to kind of like take it apart so that we're going to be able to evaluate, simplify our powers today that have rational exponents with a numerator that's not 1. So when we have b to the m over n power, we're actually looking for the nth root of a number and taking that to the m power. Okay? So look at my first one here in the practice. I broke it apart and I said 16 to the 3/4 power can be rewritten as 16 to the 1/4 power. So the denominator stayed the same. We put a 1 upstairs for the numerator, and then that 3 moves outside and becomes a power. So we have 16 to the 1/4 power, that being raised to the 3rd power. So now we have what we were doing yesterday. 16 to the 1/4 power really means look for the 4th root of 16 and then take that to the 3rd power. So the 4th root of 16 means what times itself 4 times gives us 16, and that's 2. So we end up with the 4th root of 16 is 2. That 2 is now taken to the 3rd power, and we get the answer of 8. So 16 to the 3/4 power, you did that in your calculator, you would end up with 8. The simplified answer is 8. Okay, let's practice this together now then. So number 2, 25 to the 5/2 power. So the first thing we're going to do is we're going to rename it as a power to a power. The 25 is going to be 25 to the 1/2 power, and then that numerator becomes a power outside. So now 25 to the 1/2 power, we're going to show some sort of work. We could say we're really looking for the square root of 25, and that is going to be taken to the 5th power. So we have the square root of 25 is 5, and that has to be taken to the 5th power. Well, you can go to your powers table that you have. We should have 5 to the 5th power on that. And 5 to the 5th power is 3,125. Now I want you to notice something about the difference between those two. When we took 16 to the 3/4 power, we got a number smaller than our base. When we took 25 to the 5/2 power, we got a number larger than our base. So what's the difference here? Let's look at those exponents. On the 16 to the 3/4 power, 3/4 is less than 1. On number 2, 25 to the 5/2 power, our 5/2 is greater than 1. So when we have a fraction less than 1, between 0 and 1, we should end up with a number smaller than our base. When we have a fraction greater than 1, that exponent is greater than 1, we better end up with an answer that's greater than our base. So let's look at number 3. What do you think should happen there? We have 27 to the 4/3 power. Should we get a number less than 27 or a number greater than 27? 4/3, is it less than 1 or greater than 1? Well, because it's greater than 1, I'm thinking we should end up with something greater than 27. So let's see what happens. 27 to the 4/3 power can first be rewritten as 27 to the 1/3 power, and that is taken to the 4th power. So what we're looking for is the 3rd root of 27. What times itself 3 times is going to give you 27, and then we're going to take that to the 4th power. So what times itself 3 times is 27. I get 3. That 3 is going to be taken to the 4th power. And again, if you don't know that one off the top of your head, that should be in your powers table also. 3 to the 4th power means 3 times itself 4 times. So we have 3 times 3, which is 9, times 3, which is 27, times 3 again, should get 81. Prediction held true. We ended up with a number larger than 27 because the fraction exponent was larger than 1. Okay, let's look at number 4. 1 to the 4/5 power. Okay, this is a tricky one. This one, if we look at it and say, 4/5 is smaller than 1. So does that mean that I'm going to get a number smaller than the base? Well, let's check it out and see what goes on here. This is really can be rewritten as 1 to the 1/5 power, and that's going to be taken to the 4th power. Which 1 to the 1/5 power means find the 5th root of 1, or in other words, what times itself 5 times gives you 1, and then take that to the 4th power. Well, what times itself 5 times is going to give you 1? 1 itself. And that 1 has to be taken now to the 4th power. So we're going to get 1 to the 4th power. 1 times itself, no matter how many times you keep multiplying it, you're going to get 1. So we did not end up with a number less than 1 like we thought might possibly happen. And hopefully you're starting to discover along the way here that no matter what power you take 1 to, you will always get 1, right? Okay, let's try 0 to the 5/6 power. So we have 0 to the 1/6 power. That's going to get raised to the 5th power. So we're looking for the 6th root of 0, or in other words, what times itself 6 times gives you 0, and then taking that to the 5th power. Oh, the only way to get 0 when you're multiplying is multiply by 0. So the 6th root of 0 is 0 itself, and that has to be raised to the 5th power. Well, You keep multiplying 0 times itself, you're going to get 0. So maybe you're discovering by now also that no matter what you take, what power you take 0 to, you should get 0 unless you try to take it to itself, 0 to the 0 power. Remember, that's the only thing we can't take to the 0 power. Okay, let's go to page 399, and we're going to do the check it out. Problem number 3. Get your books open to that problem. Let's see what it's about. I do have some stuff written here for us, but let's see what's going on here. Because I think we are going to have to visit the example problem above it. So the check it out problem is at the bottom of the page where it says find the number of calories that an 81 kilogram panda needs each day. Well, I think there's an equation that'll help us find that in the example above. It says the approximate number of calories, capital C, that an animal needs each day is given by C equals 72 times m to the 3/4 power, where m is the animal's mass in kilograms. So in that example, they were finding the number of calories a 16 kilogram dog needs each day. So notice what they did. They put the 16 in for the m. They simplified what 16 to the 3/4 power is first because powers come before multiplication. So we don't multiply by that 72. We leave that there up front and we find what 16 to the 3/4 power is first, which we'd already done I'd already done up here in number 1, that's 8. So now we have, in the last step there, we have 72 times 8 equals 576. So the dog needs 576 calories per day to maintain health. Okay, we're doing the panda. Find the number of calories that an 81 kilogram panda needs each day. So m, remember, is how much it weighs, the mass. So our m is 81. So we'll substitute that into our equation. C equals 72 times 81 to the 3/4 power. So again, multiplication does not get done first. Evaluating the power does. So we're going to rewrite the power. 81 is going to be to the 1/4 power, and that will be taken to the 3rd power, just like we had been doing up above. So now we're really asking ourselves, what is the 4th root of 81? And then we're going to cube that, take it to the 3rd power. So what times itself 4 times is 81. So we have that becomes 3. 3 to the 4th power is 81. And that 3 has to get cubed. So now we will do, again, we don't multiply first, we just have to do get our powers taken care of here. 3 to the 3rd power, 27. And now we finally can do our multiplication, which is 72 times 27. I want your calculator for this one. 72 times 27 should come out to 1,944, and those are calories. That's how many calories our 81 kilogram panda needs for a day. Okay, that's where we're going to quit for today. These notes come back with you tomorrow for us to finish the back side. And you use this, what we just did now, to help you guide you through the homework today and showing this kind of work. So good luck and see you tomorrow.